Welcome to today's ArXiv Computer Science Digest for June 1st, 2026. We received 1,030 new computer science papers today across 63 subfields. Let's dive into the top picks. Trend 1 of 10, Generative Models for Scientific Data. Applying generative models and advanced AI techniques to augment, synthesize, and analyze diverse scientific data. This cluster covers 77 papers. Representative work includes improving combined detection and classification of TEM defects via mass-conditioned latent diffusion augmentation towards automated discovery, a review of generative models, multimodal learning and closed-loop workflows in inverse materials design, and GlowResNet, a lightweight 3D CNN with global topological features for preterm brain injury prediction. Trend 2 of 10, Advanced System Design and Algorithms. Developing innovative algorithms and system architectures to enhance performance, security, and discovery across diverse computational challenges. This cluster covers 60 papers. Representative work includes Minddraft, a framework for batch parallel speculative decoding, Diamond, end-to-end forward secure and compact authenticated encryption for Internet of Things, and CV-Evolve, autonomous algorithm discovery for unstructured scientific data processing. Trend 3 of 10, AI System Evaluation and Benchmarking. This trend focuses on developing methods, metrics, and resources for assessing and comparing the performance of artificial intelligence systems. This cluster covers 122 papers. Representative work includes benchmarking waitlist mortality prediction and heart transplantation through time-to-event modeling using new longitudinal UNOS dataset, StableVol, disagreement-aware and stable evaluation of AI systems, and SNWER, Script Normalized WER for Multi-Script Indic ASR evaluation. Trend 4 of 10, Agent Learning and Control. This trend explores how agents learn, adapt, and control their actions within complex, interactive environments to achieve goals. This cluster covers 110 papers. Representative work includes ClinENV, an interactive multi-stage long-horizon EHR environment for agents, Hero's Journey, testing complex rule induction with text games, and skill harm, lifecycle-aware skill-based attacks via automated construction. Trend 5 of 10, Robustness and Generalization in ML, exploring methods to improve machine learning model performance and reliability across diverse, noisy, or unseen data distributions. This cluster covers 139 papers. Representative work includes paradoxical noise preference in RNNs. How many domains suffice for domain generalization? A tight characterization via the domain-shattering dimension, and robust predictive uncertainty and double descent in contaminated Bayesian random features. Trend 6 of 10, Safety, Privacy, and AI Alignment. Developing AI systems that are safe, preserve privacy, and align with human values through robust design and incentive mechanisms. This cluster covers 86 papers. Representative work includes IntraShuffler, a privacy-preserving framework for heterogeneous DP federated learning. Permissive safety through trusted inference, verifiable belief space neural safety filters for assured interactive robotics, and incentivized collaboration in active learning. Trend 7 of 10, Mathematical and Theoretical Foundations. Exploring, formalizing, and applying rigorous mathematical frameworks and theoretical concepts to understand complex systems and information properties. This cluster covers 71 papers. Representative work includes strong polarization and entropy, a formal proof of the Ramanujan-Nagel theorem in Lean 4, and pluralistic leaderboards. Trend 8 of 10, Generative World Models and Synthesis. This trend explores creating and synthesizing complex, often 3D or visual, representations of environments and data, frequently for simulation or agent training. This cluster covers 135 papers. Representative work includes Thinking in Blender, Staged Executable Inverse Graphics with Vision Language Models, RoboDream, Compositional World Models for Scalable Robot Data Synthesis, and From Zero to Hero, Training Free Custom Concept Spawning in World Models. Trend 9 of 10, LLM Analysis and Improvement. Explores methods to analyze, evaluate, and enhance the performance and capabilities of large language models. This cluster covers 130 papers. Representative work includes mitigating perceptual judgment bias in multimodal LLM as a judge via perceptual perturbation and reward modeling, probing minimalist phase structure in LLMs, what universal dependencies cannot represent, and from layers to submodules, rethinking granularity in replacement-based LLM compression. Trend 10 of 10, Research Track 10, This trend explores adaptive learning, optimization, and evaluation strategies for complex AI models across various challenging domains. This cluster covers 100 papers. Representative work includes Proto-ADA, Prototype-Guided Adaptive Adapter Expansion, and Geometric Consolidation for Multimodal Continual Instruction Tuning, VIS-Reg. Variance and variance sketching regularization for JEPA training, and VLMs are good teachers for video reasoning via adaptive test time optimization. Up next, our first paper out of 10, SafeSteer, Localized On-Policy Distillation for Efficient Safety Alignment by Hao Li and Lei Xia from Beihang University. This paper was selected because it introduces a novel and efficient method to address the critical alignment tax in large language models, a pressing problem that hinders the simultaneous achievement of safety. And let's break down its key contributions. Contribution 1. Localized On-Policy Distillation. SafeSteer is a novel method for safety alignment of large language models, LLMs. It employs on-policy distillation specifically confined to safety tokens, leveraging a safety teacher built through activation steering and a safety token selection algorithm to apply a reverse KL penalty. SafeSteer achieves a superior trade-off between safety and general capability, demonstrating strong safety performance on 7 benchmarks with minimal degradation on 5 general capability benchmarks. Contribution 2. Reduced data requirements. SafeSteer drastically reduces the data requirements for LLM safety alignment. It operates effectively with only 100 harmful samples and no general-purpose data by focusing on localized modifications through on-policy distillation of specific safety tokens. This represents less than 1% of the data used by previous baselines, significantly reducing alignment cost and making the process more efficient. Contribution 3. Mitigating alignment tax. The paper introduces SafeSteer as a new strategy to mitigate the alignment tax in LLMs. It operates on the principle that safety features are sparse, necessitating localized modifications rather than global trade-offs, which is implemented by restricting the reverse KL penalty to selected safety tokens. SafeSteer achieves the highest safety score while preserving general capability on models like Qwen 2.5-7b, Instruct, outperforming existing methods such as MOCAN, BFPO, and DPOMix. Up next, our second paper out of 10, Certified Closed-Loop Control for Packet Networks, a compositional certification framework by Mohammed Bilal and Huoming Wu from School of Computing and Communications, Lancaster University, United Kingdom. This paper was selected because it addresses a critical and pressing problem of ensuring safety and stability in complex, AI-driven critical infrastructure, offering a novel and robust certification framework that is highly relevant to the future of autonomous systems. Let's break down its key contributions. Contribution 1. Certified Packet Network Control. A certified control framework is introduced for packet networks, framing control as an executed action certification problem. A certified operator sits between any proposer and the data plane, either projecting candidate actions to executable certified actions or executing an always-defined fallback with quantified slack. This ensures operator-level safety and prevents issues like starvation, tail delay spikes, or unstable queue behavior, even with adaptive or learning-driven proposers. Contribution 2. Compositional Safety and Stability. The paper proves feed-forward compositional safety and stability for interconnected network components. This is achieved by having the certified operator export an auditable envelope for downstream composition and demonstrating a cyclic closure result under a small gain condition. This enables the modular design and safe interconnection of complex network control systems, extending safety guarantees beyond individual components. Contribution 3. Comprehensive Constraint Enforcement. A single mechanism within the certified operator covers diverse per-tick constraints, including backlog caps, service floors, mitigation caps, and Foster-Lyapunov drift constraints. The operator enforces these constraints by projecting candidate actions to satisfy a configuration-compiled certificate, ensuring adherence to predefined safety and performance boundaries. The design is evaluated under challenging conditions like delayed telemetry, delayed actuation, and overload, validating its certified execution boundary in a byte-level closed-loop backend. Up next, our third paper out of 10, Prototypicality Bias Reveals Blind Spots in Multimodal Evaluation Metrics by Subhadeep Roy and Stefan Ager from University of Technology Nuremberg. This paper was selected because it identifies a fundamental and widespread bias in automatic evaluation metrics for generative models, which significantly impacts how progress is measured and can misdirect research efforts in a critical and rapidly Let's break down its key contributions. Contribution 1. Prototypicality Bias Identification. Prototypicality bias is identified as a systematic blind spot in multimodal evaluation metrics for text-to-image (T2I) models. Metrics prefer semantically incorrect but visually or socially prototypical images over correct, less prototypical ones, even when violating the prompt. This failure mode is consequential, shaping model development and benchmark conclusions by systematically rewarding the wrong images. Contribution 2. Prototypicality Diagnostic Benchmark. Prototypicality is introduced as a controlled diagnostic benchmark across animals, objects, and demography to measure prototypicality-driven metric failures. It contrasts semantically correct images with plausible prototypical adversaries containing a single controlled semantic violation, grounded in prototype theory. Prototypicality provides a focused benchmark for measuring prototypicality-driven metric failures and developing more semantically faithful T2I evaluators. Contribution 3. Widespread metric failure on prototypicality. Widely used embedding, reward, VQA-based, and VLMs judge metrics frequently fail diagnostic contrasts on the prototypicality benchmark. These metrics consistently score prototypical adversarial images higher than their semantically correct counterparts, indicating a preference for familiarity over prompt faithfulness. This reveals a significant limitation in current automatic T2I evaluation metrics, as human judgments remain more faithful to semantic correctness. Contribution 4. Protoscore Mitigation Baseline. Protoscore is introduced as a lightweight, contrastively trained evaluator to mitigate prototypicality bias. It serves as an initial mitigation baseline specifically designed to address the identified prototypicality bias in T2I evaluation. Protoscore offers a promising initial step towards developing more semantically faithful T2I evaluators, addressing a critical blind spot in current evaluation practices. Up next, our fourth paper out of 10, Cryptomania vs. Minicrypt in a Quantum World by Longqing Li and Qiping Liu from University of Cambridge. This paper is selected as the top choice because it resolves a long-standing open question in quantum cryptography by proving a fundamental impossibility result regarding perfect complete quantum public key encryption, which has profound implications for the future. Let's break down its key contributions. Contribution 1. QPKE impossibility with classical keys. It is impossible to construct perfect complete quantum public key encryption, QPKE, with classical keys from quantumly secure one-way functions, OWFs. This impossibility is proven in a black box manner within the Quantum Random Oracle Model, QROM, demonstrating no such scheme can be secure with classical or quantum ciphertext. This finding resolves a long-standing open question in quantum cryptography, establishing a fundamental boundary for QPKE constructions. Contribution 2. Improved impossibility proof robustness. The paper presents a stronger impossibility result for perfect complete QPKE with classical keys and classical/quantum ciphertext. The proof avoids reliance on unproven conjectures and removes imposed restrictions on key generation algorithms, which were present in previous works. This significantly improves prior works by providing a more robust and general understanding of the limitations of QPKE from OWFs. Contribution 3. QPKE impossibility with quantum public keys. The established impossibility result for QPKE is extended to schemes that utilize quantum public keys in natural settings. The proof technique is generalized to cover scenarios where the public key itself is quantum, not just classical. This extension provides a tight boundary for all known QPKE constructions that employ quantum public keys, clarifying their fundamental limitations. Up next, our fifth paper out of 10, Interventional Processes for Causal Uncertainty Quantification by Hugh Dance and Arthur Gretton from Gatsby Unit, University College London. This paper was selected because it introduces a fundamentally novel Gaussian process-based approach for reliable uncertainty quantification of entire interventional functions in causal inference, addressing a critical and challenging problem in high-stakes applications. Let's break down its key contributions. Contribution 1. GP-based causal uncertainty quantification. A novel Gaussian process, GP-based framework is introduced for uncertainty quantification of interventional functions, addressing a critical gap in causal inference for function value targets. The framework builds on representing interventional functions as an inner product of observational functions in a reproducing kernel Hilbert space, RKHS, by constructing appropriate GP priors and inferring posteriors from observational data. Up next, our sixth paper out of 10, Auto-Formalization of Gödel's Second Incompleteness Theorem in Binary Recursive Arithmetic by Thierry Coquand from University of Gothenburg. This paper was selected because it demonstrates a landmark achievement in AI-assisted formal verification, showcasing the surprising capability of large language models to auto-formalize a foundational mathematical theorem like Gödel's second in. Let's break down its key contributions. Contribution 1. Auto-formalized Gödel's Second Incompleteness Theorem. Gödel's Second Incompleteness Theorem for Church's Basic Recursive Arithmetic, BRA, was auto-formalized in AGDA. The resulting AGDA development comprises approximately 50,000 lines and contains no postulates. The entire formalization was produced through interaction with Claude, a large language model, with the author writing no AGDA code. The process followed the proof outline given in Gard's 1963 lecture notes. This provides a fully machine-checked proof of G2IT for BRA, clarifying details left implicit in the original presentation and representing a significant achievement in auto-formalization. Contribution 2. LLM Strengths and Limitations Case Study. The project provides a case study demonstrating the strengths and limitations of current large language models in mathematical auto-formalization. An initial autonomous attempt based on a false theorem by Rose resulted in Claude producing a development mathematically unrelated to Gödel's theorem due to an insufficient specification of the internal provability predicate. This illustrates how an LLM may reason correctly from an incorrect formal specification, emphasizing the critical importance of precise input specifications for reliable auto-formalization. Contribution 3. Reconstruction of implicit mathematical arguments. The formalization of Gödel's second incompleteness theorem necessitated the reconstruction of several implicit mathematical arguments from Gard's original presentation. This reconstruction involved clarifying the role of the internal numeral encoding operation and the interaction between substitution and numeral closure. The resulting formalization clarifies a number of details left implicit in the original presentation, providing a more explicit and rigorous understanding of the proof for BRA. Up next, our 7th paper out of 10, Tridirectional Discriminating-Power Formal Verification of Smart Contract Reentrancy Defense Against Production-Deployed Solidity Source by Reyes Condor. This paper was selected because it presents the first machine-checked correctness proof of a critical smart contract security pattern against production-deployed code, directly addressing a pressing and costly problem in blockchain security with unparalleled rigor and impact. Let's break down its key contributions. Contribution 1. Machine-checked reentrancy guard proof. The first machine-checked correctness proof of the OpenZeppelin reentrancy guard pattern against a lean 4-state machine model of production-deployed Solidity source was presented. All 13 theorems are machine-checked with zero user-introduced axioms, and an axiom footprint bounded by protext. This was achieved by developing a lean 4-state machine model of production solidity and formally verifying the guard's behavior, ensuring rigorous mathematical proof without relying on unproven assumptions or user-defined axioms beyond a standard mathematical one. This provides unprecedented formal assurance for the de facto reentrancy defense, addressing a vulnerability that has caused over US $500 million in documented losses and establishing a new standard for smart contract security verification. Contribution 2. Discriminating-Power verification. The paper establishes and verifies the concept of discriminating-power for the OpenZeppelin reentrancy guard, demonstrating it blocks attacks on vulnerable instances, preserves correct execution for non-attacking transactions, and distinguishes adjacent safe and vulnerable variants. This was achieved through a tridirectional verification structure involving A. Attack reproduction for DAO 2016, B. Correctness proof for Compound v2, and C. Boundary case proof distinguishing Aave v3's safe flash loan from a minimal diff mutant. This goes beyond prior work that only formalized toy contracts or attack feasibility, providing a comprehensive and rigorous verification methodology for production-deployed smart contracts and their defenses, crucial for preventing future multi-million-dollar exploits. Contribution 3. Production protocol verification and mutation testing. The work verifies 3 production instantiations, DAO 2016, Compound v2, Aave v3 flash loan, and a minimal diff mutant, flash loan vulnerable, of Aave v3, isolating a single security critical structural difference. A mutation testing methodology was applied to formal verification by constructing the flash loan vulnerable mutant, enabling a controlled experiment to precisely identify the impact of a single structural difference on security. This approach provides stronger guarantees than verifying only safe contracts, demonstrating the guard's effectiveness against real-world vulnerabilities and its ability to differentiate subtle security flaws, which is vital for robust DeFi security. Contribution 4. Composable metatheorem for cross-protocol verification. A capstone metatheorem was developed that composes the proofs of the 3 protocol instantiations under a no-retrofit discipline, demonstrated at the first cross-protocol stress test, Compound v2 to Aave v3. The metatheorem combines the individual protocol proofs without modification, ensuring that the composition itself is machine-checked and maintains the integrity of the underlying verifications. This establishes a framework for composable formal verification, allowing for the secure integration of verified components across different protocols, which is essential for the growing complexity of the DeFi ecosystem. Up next, our 8th paper out of 10, Non-vacuous Generalization Bounds for Deep Neural Networks Without Any Modification to the Trained Models by Coat, Then, and Dat Fan. This paper was selected because it addresses one of the most fundamental and long-standing theoretical challenges in deep learning by presenting the first non-vacuous, directly computable generalization bounds for trained deep neural networks, including large dash. Let's break down its key contributions. Contribution 1. Non-vacuous bounds for unmodified DNNs. A new class of data-dependent generalization bounds is introduced, which is exactly computable and non-vacuous for unmodified deep neural networks, including ImageNet scale models with 600M parameters. The approach reveals that generalization is governed by the interaction between the trained model and the geometry of the data distribution, decomposing the error into distributional complexity and local model behavior terms. This is the first work to show that meaningful generalization guarantees are achievable for large, unaltered deep networks, overcoming limitations of prior methods that required model modifications or applied only to small models. Contribution 2. Decomposition of generalization error. The generalization error is decomposed into 2 interpretable components, a distributional complexity term and local model behavior terms. The distributional complexity term captures how data mass is distributed across the input space, while local model behavior terms capture the network's behavior within individual regions. This decomposition provides insight into where and why generalization gaps arise, highlighting the joint dependence on model behavior and data geometry. Contribution 3. Predictive power and bound tightening. Some components of the proposed bound are highly predictive of the true test error empirically. The bound tightens when the partition aligns with the intrinsic data geometry, demonstrating the importance of data-dependent local regularity. This empirical finding suggests that the identified components are crucial drivers of generalization, offering a path towards more accurate and tighter generalization guarantees. Up next, our 9th paper out of 10, To See or to Please. Uncovering Visual Sycophancy and Split Beliefs in VLMs by Rui Hong and Shushu Quan from George Mason University. This paper was selected because it uncovers a critical and surprising failure mode, visual sycophancy and split beliefs, in state-of-the-art vision language models, providing a novel. Let's break down its key contributions. Contribution 1. Tri-layer diagnostic framework. A tri-layer diagnostic framework was introduced, featuring latent anomaly detection, LAD, visual necessity score, VNS, and competition score, computer science, as per-sample metrics. This framework dissects VLM decoding into perception, dependency, and alignment layers, quantifying each with metrics computed under counterfactual blind, noise, and conflict images to reveal a split beliefs pattern. It provides a sample-level decomposition and a 4-category taxonomy: perceptual blindness, language shortcut, visual sycophancy, robust refusal, of VLM failures, applicable to any existing benchmark without new probe data. Contribution 2. Dominance of visual sycophancy. Visual sycophancy was identified as the dominant failure mode, present in 72.9% of samples across 9 VLMs and 9,000 model sample pairs, while robust refusal was absent in 0% of samples. This discovery was made by applying the tri-layer diagnostic framework under counterfactual interventions, which revealed a split beliefs pattern where internal visual evidence is preserved but a hallucinated answer is decoded. This finding indicates that current alignment training has eliminated refusal as a decoding outcome, highlighting a critical grounding problem where models internally recognize visual anomalies but still output committal hallucinations. Contribution 3. Scaling effects on VLM failures. Scaling within the QuenVL family, both within and across generation, monotonically reduces language shortcuts but amplifies visual sycophancy. This effect was observed by applying the tri-layer diagnostic framework to different scales and generations of QuinVL models, measuring the prevalence of specific failure modes under various interventions. This demonstrates that scale and newer post-training alone cannot resolve the grounding problem in VLMs, suggesting that current scaling strategies may inadvertently worsen certain types of grounding failures. Contribution 4. Diagnostic-guided selective prediction. A training-free selective prediction strategy was developed, leveraging the diagnostic scores. This strategy utilizes the latent anomaly detection, LAD, visual necessity score, VNS, and competition score, computer science, to selectively filter out unreliable VLM outputs without requiring any model retraining. This method achieves up to plus 9.5 percentage points accuracy at 50% coverage, offering a practical and efficient way to improve VLM performance and reliability. Up next, our 10th paper out of 10, ProbMoE, Differentiable Probabilistic Routing for Mixture of Experts by Heng Zhao and Zhe Zeng from Department of Computer Science, University of Virginia. This paper was selected because it introduces a novel and principled probabilistic framework for mixture of experts routing, directly addressing a critical challenge in scaling large language models by enabling differentiable and stable training. Let's break down its key contributions. Contribution 1. ProbMoE Exact K Routing. The paper introduces ProbMoE Exact K Routing, a method for selecting a fixed number of K experts per token in mixture of experts models. It samples K expert subsets in the forward pass, and its backward pass computes gradients using each expert's exact marginal probability as a tractable surrogate. This approach achieves strong performance with improved expert utilization and routing diversity compared to competitive baselines, resolving the non-differentiability of top K routing. Contribution 2. ProbMoE Dynamic K Routing. The paper generalizes ProbMoE to dynamic K routing, allowing for a variable number of activated experts per token. This method constrains the routing cardinality to a predefined range during both training and inference, enabling adaptive expert allocation. ProbMoE Dynamic K achieves comparable performance to fixed K methods while utilizing fewer activated experts, leading to potential computational savings. Contribution 3. Probabilistic Routing Framework. A novel probabilistic routing framework, ProbMoE, is proposed for mixture of experts models. It models expert selection as a distribution over cardinality-constrained expert subsets and formulates routing as a probabilistic inference problem. This framework fundamentally resolves the non-differentiability issue of traditional top K routing, leading to improved training stability for large-scale AI models. That's all for today's ArXiv Computer Science Daily. If you found this helpful, please like, leave a comment, and subscribe for daily paper summaries. See you tomorrow.